You're welcome to Olusegun Maths Clinic. Today we are solving a questions from the theories of logarithm, and we are to find the values of x. Before starting this question solving it, don't forget to subscribe to our YouTube channel and like our Facebook page. Also try to share this video everywhere you know that it's good to share it. So thanks for that. So now, in solving a question in this form, most important thing to consider is that there is some rules guiding the theories of logarithms. And the first rules is that we're going to apply here is change of base rules. You must apply the rules of change of base. After applying the rules of change of base, you're able to know to now manipulate and able to substitute some values. Let's start. So now, in having this, there's a law that says log p base a, or let's say log p base q, can be written as log p base a over log q base a. This is the law that we call the change of base, the laws of change of base. It is being used in theories of logarithm. So therefore, we apply these rules to these questions. So now, we said log x base 3 plus. So this, let's change the base of this log 3 base x. Let's say we have a log 3 base 3 divided by log x base 3 is equal to 10 over 3. Now, with this, there is another rule says that the logarithms of the same base, the logarithm of the same base will surely give us 1. So having log 3 base 3 must be equal to 1. So let's rewrite this equation back to have log x base 3 plus, so for writing this we have 1 over log x base 3 is equal to 10 over 3. Now, having this, let's try to represent log x base 3, let's represent it by m. So instead of writing log x base 3, let's write it as m plus 1 over, this is also m is equal to 10 over 3. So now, most important factor is let's multiply the equation by 3m, because the 3 and m and the 3 are the one in the denominators. So we have 3m dot m plus 3m dot 1 over m is equal to 3m dot 10 over 3. So this will give us 3m square. M will cancel m here, plus 3 is equal to 3 to cancel this, we have 10m. Before I move further, maybe from your mind of a lame mathematics student or somebody that just viewed this video, why am I multiplying by 3m is that I want to turn this fraction, these two fractions, to linear. So I must multiply with the lowest common multiple. So now the lowest common multiple is 3m. So that's why I try to, so in changing it to linear form, will make us to understand what next to do. So it has now changed to linear form now. we have 3m squared minus 10m plus 3 is equal to 0. So we are able to have gotten it has turned to quadratic equation. So let's try to, it can still be factorized because this is 3 times 3 will surely give us 9. So we have two numbers that by the time you add it together, it will give us minus 10. And by the time you multiply, it will surely give us plus 9. So let's try to expand this to have 3m squared minus, this will give us minus 1m, let's say minus m, minus 9m. But by the time you multiply minus 1 and minus 9, will give us plus 9. Plus 3 is equal to 0. So from here, what is common? M is common. We have 3m minus 1. Here, 3 is common. We have minus 3 is common. We have 3m minus 1 is equal to 0 because by the time you multiply by minus 3, it will surely give us minus 9. Minus 3 times minus 1 will give us plus 3. So let's try to group it and see what we have. We have m minus 3 onto 3m minus 1 is equal to 0. So I used to say something in my previous video that anytime you are having two values multiply and it gives us 0, it lets us to know that it is either the first one that is equal to 0, or the first one is equal to 0, or the second one is equal to 0. So that's why we have the right to write it in the form that m minus 3 is equal to 0 or 3m minus 1 is equal to 0. So therefore m is equal to 3 or 3m is equal to 1. M is equal to 3 or m is equal to 1 over 3. So this is the value of m. And we have been able to represent the m to be log x base 3. So let's consider when m is equal to 3. So let's consider when m is equal to 3. And we have our log x base 3 is equal to 3. My brother, there is another rules in logarithms. In the theories of logarithm, you must consider here. The law says that log p base a is equal to x. In any time you have a value like this, your p will be a raised to power x. That's just the meaning. So let's apply these rules to this. Let me try to so let me use here. So now, in applying these rules to this, it means that log x base 3 is equal to 3, meaning that our x will be 3 raised to power 3, and 3 raised to power 3 is equal to 3 times 3 times 3, whereby x is equal to 27. This is one value of x. Let's also find another values of x. So let's try to do that. When m is equal to 1 over 3 and our m is a log x base 3 is equal to 1 over 3. So therefore, from applying these rules, x is equal to 3 raised to power 1 over 3, which is the cube root of 3. So the two values of x is equal to 27 or x is equal to the cube root of 3. So these are the two values of x. We can also cross-check our answer. Maybe we are right or we are wrong. Let's try to cross-check the answer from here. So when x is 27, let's try to do a meaningful fact. When x is equal to 7, we have 27, we have log 27 base 3 plus a log 3 base 27. Let's see what it's going to give us. So we have a log 3 raised to power 3 now plus log, let's try to change the base now. The base, we have a log 27 base 3. So this will give you 3 log 3 base 3 plus this will give you log 3 base 3 over, this is also from here, we have a log 3 raised to power 3 base 3. This is another ways. We want to cross-check, maybe our answer will be 10 over 3. So now, this will now give us, I've said it earlier that the logarithm of the same base is equal to 1. So here will give you 3 times 1 plus 1 over, this one will come down, 3 times 1. So which is will give you 3 plus 1 over 3. So now let's try to find the LCM, which is equal to 3. So from here, this is over 1. So 1, you have 9 plus 1. So this is because, therefore, we have 10 over 3. So it gives us this. So it shows that our answer from this question is correct. Let's also cross-check when s is 3, the cube root of 3. Let's cross-check that to know maybe we are right or wrong. So let's cross-check. So we said the log, the 3 raised to power 1 over 3 base 3 plus log 3 onto 3 raised to power 1 over 3. So now let's also apply 1 over 3 log 3 base 3, because this one will come down, we come to this side. Let's change the base, log 3 base 3 over log 3 raised to power 1 over 3 base 3. So this will give you 1 over 3 times 1 plus, this is 1. 1 over 3 log 3 base 3. So this will give you 1 over 3 plus, this will be 1. 1 over 3. So it means you have to reciprocate this, meaning that 1 over 3 plus 3 over 1. That is the meaning. What is the LCM? 3. So we have 3 and 3, we have 1 plus 9, which is also 10 over 3. So telling us that our answer for this question, the first one is is 27, the first value of x. The second value of x is the cube root of 3, is correct. So this is a nice radical theories of logarithm question. A nice radical theory of logarithm question, which I believe when you see any question relating to this, you must be able to know what to do and how to solve it with just a simple rules, which we call change of base. So please don't forget to subscribe to this channel and share this video. Thanks for watching.